1. We're still on example 1, and we're finishing off D. So finishing off D, and we're at the point where talking about the exact where possible. So this one can be exact. We'll talk about that one in a minute. But this one, even without looking at this one, here it's 1/2, right? So it's not a pretty, right, a special angle. So I'm going to have to go to decimal. I asked you, I didn't tell you what decimal. I didn't say anywhere? Oh, I should have said. So it doesn't say anywhere. Solve on the interval. Okay, I will have to tell you, usually we tell you at the beginning of the test on the instructions what to round to. So for the radians, we usually round it to 4. So I'm going to say, and again, the instructions would be round radians to 4 decimals. Okay, and it might be 3, but read the instructions. So if the instructions say radians to 4 decimal places, I want you to keep 5 or 6 in the question, right? So you want to keep a little bit more, just because of the double rounding effect. Okay, and I purposely chose this one, I think, or wait, maybe it's the next one, 6, 4, 5, 2, 6, 3, 6. Oh, it was. Okay, so here. So knowing that, when we do this and we put this into our calculator, we're going to do inverse 10, well, I'm in degrees, so switch to radians, so 2, inverse 10, 5, whoops, 5, like this. I'm getting x is approximately, so this is x1, 0.4636, but then if I keep an extra decimal place, it's 4.7, which rounds to 5, right? But then, if I round it to 5, then when I go to my final answer, don't double round it. This is where, and so I purposely picked this one because this was where people go, wait. Okay, so I get this answer, and if I said keep 5, I go 0.4636, it's 3647, and you round it to 5 radians here. But then, do you see what happens? When you do your therefore statement at the end and you round it to 4, you end up rounding it to 7. And is that what it should be rounded to? No, because of the double rounding. So that's the problem with the double rounding, because, and this is the case. I purposely chose the 1/2 because this is where it happens sometimes. I say 4, and you go, okay, but it's 0.5, and then you look back at it at the answer and go 5 rounds to 7, so now it's 7. So you have to remember that this did round to the 5. So when you put your answer, I need you to put 4636, not 7, because otherwise it's double rounded. If you want to and you're like, that's going to confuse me, keep 4.8. You go, you know what, that 5 is going to throw me off at the end. So that's where I said, even keep an extra one. An extra one would be better than double rounding. If you double round, I'll have to take off half, because I'm like, you rounded at 5, which rounded it to 7, which is wrong. Right? So if in that case you're like, I'm not going to remember, then keep, so I'll put down over here, then, or you can keep, this one would be 4.8, so 4.8. Does that make sense? Right? So if you need to keep an extra decimal place rather than round it twice. I've seen students with the tan of 1/2, and I'm like, what's happening? Because they rounded it once, twice, and you're off now. Okay, so that's where the double rounding comes into not good play, right? Because that goes to 5, and then you go 5 is 7, and it's not, right? It's 3, 6. Okay, so just be careful there. So it's good if you leave the 5, that's okay, but on the answer, make sure you keep it at 6. It doesn't double round. So it's up to you. Is that going to confuse you if I leave that there? Should I take that off? Right, so I'll take it off. I'm wondering if I leave it there, it's going to look funny. It's okay? Right, so it should be 4.8 if you want to keep it, so I'll leave it there. Okay, I'll leave it there, and hopefully you understand what I mean. Then for x2, so now we're going to cast rule. Tan is positive here and here. So we're going to go x2 is going to be pi plus 0.46365, right? And then I'm getting approximately, I'm putting the approximate wherever I round again. So here I didn't round because I took my answer. Next step I rounded, and I got 3.6052 radians. Stop me if I'm wrong, please. Right, and that's rounded to 4. So I kept the 5 just in case I didn't want to do something, and then now I'm keeping it 4 because that's my final answer. For this guy here, for this one, so I'm not done. Remember, these are double questions. Okay, so this guy here, tan x. If you want to, whenever it's negative, I switch it to positive. So remember, this is my RAA. Okay, and you don't have to. If you're good with the negative, some people are like, no, I get it. The negative would get me a negative, and then I would flip it around myself, and I don't need help anymore. But in grade 11, I remember, in the beginning of this course, I would do the related acute and then switch it to the proper quadrant, right? And that does help a lot of people. So then I know it's in quadrant. Which two quadrants is it in? C and this one. So here and there, right? So we're going to go here and then around. So my x, I'll call it x3. I don't care about the numbering, just they have to be called something different. x3 would be, oh wait, and b is what? How much is b? If it's 1? Pi over 4, yes. Right? So you should hopefully recognize it's 45 degrees. Opposite to adjacent is 1 over 1, so it's pi over 4. Right? So I'm hoping that I'm going a bit faster now because you're recognizing the special angles. 1 over 1 is pi over 4. So then I know for x3, that would be 3 pi over 4. And then x4, I don't care about which number is which, just we got 4 different answers now. And we were going to get 7 pi over 4. So 2 for this one, 2 for this one. This is exact, this is approximate. Okay, and you're deciding when you can keep it exact and when you can't. I know that part is difficult, right? And then final answer, put all your answers together. So I'm getting 4. I don't care about the order. Try to go in an increasing, but I'm just going to go with the decimals first. 0.4636 radians, because again, right, so this part here, right, keep that. So just be careful. And that's from the 48 here. So this one here, because it's 4/8. Which rounded to 5, so keep that a 6, is where I get some people double round. And I have to go backwards and try to figure out what happened. And I found out that, oh, because you rounded it once, kept an extra, but then rounded it again. So I wanted to show you that. Right, so that's where the double rounding is a problem. Okay, then this guy is okay. So 3.6052R. And then 3 pi over 4 and 7 pi over 4. And I got 4 answers. Questions, clarification?